So, yeah, thank you very much. After lunch, and then you join my session. So, welcome. And this talk will be beginners friendly. So I won't dive deep down into the detail of like how the package work and all this. If you are into something really technical, I'm sorry, maybe lagging, but I'll tell you how I use the package and what is the a theory behind and how I use it. Just some tips for people who may be using it in the future. And it's like it's a PyData style, so here who is kind of like identify themselves as data scientists, analysts working with data. Yeah, great. So I hope you will find it useful. So yeah, that's my Twitter there and GitHub, and you will find the code on GitHub actually. And also remember to tag EuroPython, and please rate my talk afterwards. So thank you. Okay, and then I'm Cheuk, or you can call me Cherry, my friend does. And I'm working in Hotel Beds. I'm organizing an AI club for gender minority, which is in London. So I'm based in London. So we are trying to promote gender equality in the technology. So trying to encourage and empower gender minorities, like mainly women who is like struggling, feel a bit, not enough support in the community, so we try to help. Also, I'm a member of Python Sprints, so if you are, like me, coming from London, and then next week we will have a sprint for pandas documentation, so which is for gender minority. So if you are minorities like me and you want to start contributing to pandas, or other, we will have other events for other libraries as well. So if you want to contribute and you don't know how to get started, you're welcome to join. Or if you're super senior, you're like very experienced, and you're welcome to help out as well. So yeah. Okay, all of those things clear. So why we are doing this like matching company names, like string matching, and so yeah, I was having a problem at work. Like I want to match, like there's a list of companies, which is my company's client, and I want to find the some similar names in it. But of course, it's not limited to my company, right? So like why we want to match the name? So I have some kind of funny encounter on Facebook actually, because somewhere in China I saw this pictures. Looks familiar, right? Okay. What about this one? It's giving credit to a company in USA, obviously. And this one. Okay, I have to quickly skip through it because it's a very nasty typo there. So if I want to see if, if I have a list of company and some of the company like those, I want to see, are they the one that the coffee shop that we drink coffee and we buy cakes, and are they the same? So can you tell me what would the result of those? Yeah, all false. So I can't do it like that, right? Everybody knows that. So maybe I can be smart. Maybe I can use some string methods to do it. So who knows what string method I could use to make the first one become false, like to do some modification. Yeah, up or lower. How about the second one? There are different ways, but I found a way to do it, which is I'll show you. And what about the last one? Let's talk about the last one. Yeah, I will show you the thing that I could think about. I replaced the spacebar and I just trimmed the S. It's a bit stupid, right? What if it's not like Starbucks? It's like Starbucks exclamation mark, then it doesn't work, right? So we need something else to kind of find all these similar strings. So I kind of know this one. It's called fuzzy matching. It's just a funny name. It's like fuzzy. You're thinking about cute animals they're but yeah, that's Wikipedia's definition. It's too long. I just don't like to read long paragraphs, but actually basically what it means is just matching two strings that is not exactly the same, but we want to find a way to score them, how similar they are. So voila, we have something very smart coming up. So this is kind of named after a Russian scientist. I hope I pronounce it right. If you speak Russian, then yeah, you can tell me. It's Vladimir Levenstein. Is it correct? Levenstein. Yeah, Levenstein's distance. So yeah, I'm still doing it wrong, but yeah, forgive me. Yeah, so it's basically telling there will be a number. An integer that says like, oh, how much alternation I have to do from changing string A to string B. So if I delete one character, there will be one change. If I change that, like for example, from an A to an E, that would be also one alternation, and or adding something. So yeah, so if that number is bigger, this the Levenstein distance is bigger, then the two strings is more different. So it sounds very intuitive, right? So how can I do it in programs? Of dynamic programming, it sounds smart, right? But actually, yeah, I got this picture. It's not my picture. I should give credit. It's from GitHub. Actually, there is a JavaScript library that is implemented this. But of course, I'm using Python, so I'm not talking about that packages. But yeah, if you find my slides and you can click on it, and you will go to there and like have a look at their GitHub repo. So this is the graph, right? Or matrix. I don't know how you should call it, but you can see like from the top left-hand side, it's 0 because there's no change. And then if, okay, we just go from one character to one character, so first character, they're the same. So if you, so basically, you don't need to change anything. So they will be the same, right, both S. But you can see like, for example, if I go one step to the right, I'm adding one word to Saturday. So if I spell Saturday, it would be adding one word each. So it would be, you can see the first line is 1, 2, 3, 4, 5, 6, 7, 8. And if I go down, it's like adding words to Sunday, so you can also see that as well. So it's from 0 to that word. So what if I have, now I have two characters. I have, for example, Saturday, I have like SA. If I want to change it to like Sunday, so it's like S should be SU, right? So I have to change the A to the U. So if you look at the intersection of the A and the U, there will be 1. So you have to change one character. So this is what this is. And of course, it's dynamic programming. So it's like, so if you first you have the small problem, and then you can expand it until the end. And at the end, you can find that the minimal change is free. And then you can work your way back up and find the path, the minimum path that you have to do to change Saturday to Sunday. So yeah, you can see there's some transformation, some deletion, which yeah, you can see from the graph. So I'm not talking about that repo because that is in Java. So JavaScript, I believe. Yeah, JavaScript. So yeah, and so I'm using Python, so which is I can use Fuzzywuzzy, which is also a funny name, which I love. So why I use that is like, what is it like better that I really like it that much is because it's not just using the Levenstein distance that I can compare two strings. It also provides some some features that's very useful. For example, simple ratio, which is which is the basic one, right? So that one is not magic, that's basic. But we can also have partial ratio, which means that if I have, for example, two words, that, for example, my name is like, I'm Cheuk, but also if you include in my middle name like Cheuk Ting. So Cheuk and Cheuk Ting, are they the same person? Is it both me? So if I use partial ratio, that would be the same, right? Because Cheuk Ting also contains Cheuk, because it's also my name. So that would give you a score of 100, so they are the same. But if you use simple ratio, it won't be the same, because you have to add Ting at like 4 characters to become my name, right? So so that would give you a lower score. For this Fuzzywuzzy matching score. And also we have a token sort ratio, which means that I token each word. and then they can change the order. For example, my name is Cheuk Ting Ho, which Ho is my surname, but in Chinese, we have surname first. So my name will be actually Ho Cheuk Ting in Chinese. So so it's the same person, so I have to use a token sort ratio. So that would be actually still like the three names are the same, so it's just the order is changed, and because Western culture usually put your give a name first and then your surname, but in Chinese it's different. So yeah, it's still the same. It will give you 100. And then for token set ratio, that would be like, for example, my name. Because for example, you will skip the middle name, right? Usually, if I put my first name and my last name, there would be Cheuk Ho. So then that would be, is it the same as me? And then it would do the token ratio, and also if it's a subset, then it will also pass. It will also give you a 100 score. So that's very useful. It depends on the use case. Actually, it would really help you out. So you can check out the GitHub repo. It's done by Sidki. It's a very, very popular library. I used it and I really like it. So you can go there, check it out, and they have a blog post about what the difference between these four as well. So yeah. Okay, so my use case now. I have the company data, but of course I won't use my my company's client's data because that's confidential. So I download an example data set, which is from the open license public database, which all the UK companies, if they have limited liability, they have to have all these information in public. So you can download it. So there's a lot of company actually in this country. So I only use Cambridge because a lot of startups going on there is very exciting. So, but still, there's a lot of company in that list. It's like 15K, so quite a lot. Okay, so trick one, because if I just use Fuzzywuzzy and I just check all these names, are they the same? Actually, a lot of them will be having a high score because there's some words that all the company use, right? You can have I can have my own, Cheuk Ting company or whatever, and everybody can set up a company with the name company. It's a very common idea, right? And limited is very common as well. So that would be less meaningful to match them. For example, if it's talking about my clients, a lot of them, because my company is doing travel, like hotel rooms and stuff. So a lot of my clients, they will have travel in the name, so which is less meaningful. So what I do is I use a small trick that I do all this count dictionary and I see what's the 30 most common words. Actually, this is also useful in doing some NLP stuff as well. So recurring theme. So very convenient. I just use the same idea to do it. Okay, and then another thing is I came across a problem because there's 15, almost 16K companies. So there's a lot of number. If we match each single one of them with the others, that would be a lot to compare, which I don't want to have a big project, right? I don't want to have a GPU and all this stuff to train it, to calculate for a day. No, it's not going to work. So and Python is not super fast. So that's why I am trying to use some trick, because I'm thinking about I want to match companies the name that's highly similar. So I would just assume that they won't make the mistake on the first character. If for example, if somebody make an account, type in a company name, but made a mistake, have a typo, and oops, it's wrong. Or I will open another account with the right name. So basically, a person opens two accounts with highly similar names because I made a mistake on the first one. So I just assume that they won't make the mistake in the first character because that's very obvious. Usually you type something, you just have a look at it. If the first character is wrong, you just catch it. So that's the trick that I do. That's good enough for me. Okay, so remember I found out the 30 most common words, right? So when I do fuzzy matching, I would deduct 10 points. It's like a game, right? It's because you have this word, I'll just deduct your points. Because, because I will check the score at the end, right? I'll check if it's having a high score. So if they just have a score, this pair having a score just based on they have a common word, so it's not valid. So I have to deduct the score, so to make them to balance it out. Is it a very good trick? It may not be, but it works, and it's very simple. It's very easy to implement, so that's why I do it. I think in a lot of cases it will work. Yeah, it sounds very simple, but it works. So, and also I choose to use this token sort ratio because if somebody, for example, if somebody type in the names, if they swap it, so they should be highly similar, right? So I'm considering it like in a word by word. So I choose to use that. Sorry. Okay. So at the end, what do I find out using that data set? You can go to my GitHub and check it out. It's just a very Jupyter Notebook. It's just very simple, and as an example that you could just simply reference back. So the thing that I caught, like if they score a score that is like more than 85, then they would be considered the same. So what are they? Usually they would be like spelling mistakes because they would be like two names that's different by, for example, just an S, like the Starbucks and Starbucks. Or they would be having one less L or one less I or things like that. So it's very easy to make those kind of mistakes because if it's an I and an L, obviously, if you look at it, then it's very easy to miss. So it kind of makes sense for human typo. It may not be, but I just suspect that is. And also, number 3 instead of number 2, so that one it will be, I would suspect somebody having multiple accounts, right? For example, if I sign up with an account with a username, I already did it last week with my name, and then this week I want to have another one, I'll just put a 2 at the end. So that's the logic. Sorry. So, and also there would be, like, for example, a abbreviation. There could be some changes, so that could be intentional. So I won't suspect that would be absolutely a human error. And also, that's the funny thing that I found, because like some names, they actually, they look similar, like the one that I have here, but they are not just different by one character. It could be they are just like two companies that's coincidentally having a very similar name. So that's the interesting one that I would love to investigate. You see, like for example, if they are my clients, I would maybe ask my colleague if they can talk to their clients and like, oh, are they like the same? Is still like the two accounts belongs to you, or is it if somebody is like coincidentally having like a similar name? So yeah. That we need some checking, human checking at the end, but actually I can show you it's actually highly reduced the work that we have to do to find out if it's a typo or is it totally two clients, because you see after I applied the matching, so it's like the one that got caught, there's like highly similar. It's only 1% of the total. And so among like 15K that you have to maybe look at it, at least like you won't call all of them, right? I won't, like, of course my colleague won't call all of the clients, but like by just looking at them, you can like you still have to do like go through the long list of like that much, like 15,889. But now I just need to look at 57 of them. So, and also maybe investigate in 57 of them. So it really highly reduced the work that you or your colleague have to do. So I think it's a really good trick. So yeah. So yeah, happy matching. So I think I have a lot of time left, is it? And yeah, I just go through it very quickly, is it? So.
Thanks, just Cheuk, for
just ask questions and yeah.
Thank you very much. Yeah, so we have time for questions. Yeah.
So the Fuzzywuzzy use 4 metrics to estimate if it's a match or not. What is the, let's say, the coefficients or the priority of these 4 metrics?
You mean the...
Like the token sort order?
Yeah, so 4. I can actually show. They are doing it, they're actually giving it a score, like it will return a score at the end, which if it's perfectly matched, or if it's, there's actually examples. Like for example, if, like here, for example, the token sort matching, you can see like, let me make it bigger.
Yes, but how it eventually generates this final score from that 4 metrics?
Yeah, so basically what it's doing, if it's just, for example, if it's just simple ratio, it will be Lorentz distance and then just, normalize it and give it a score. If it's, I haven't really checked in the code of this, but it will give you 100 if it's a total match, you can see here. For example, if it's a partial match, then it will give you 100 if it's a totally match. So it's by proportion as well. So if you have a longer phrase, then if it's the tolerance of the difference, it will be higher because it's by proportion.
Oh, okay, so you pick which one you want to use. It's not like eventually they combine the 4 to generate one score.
Yeah, you can choose which logic you want to use because, for example, if I apply this in the simple ratio, it won't be perfect, right? So it's the logic that you could choose. Yeah.
Thank you.
Okay, we have another question.
Yeah.
Hello. So I was curious that Wallenstein only uses for letters. So does it work equally well in all languages, or are there some languages that it has problems in? And do people use techniques like combining it with the dictionary from a language to get better results?
Actually, because it doesn't care what languages it is. It's the idea is like it checks characters, and if, for example, if it's not in English, if it's in French, then it doesn't matter, right? Because like if you have if you have a word that is 1 character difference, it will give you a score of like a Lorentz distance of 1, because there's 1 character difference. So it doesn't matter if it's a change of that character, if it's deletion, or if it's adding 1 character. Yeah.
This is kind of more of a question of what if. Suppose I've got 2 super big tables, and there are like World of Warcraft players from one server and another server, and I kind of want to know if there might be a match. And let's assume that these names are fuzzy. Not the best example, but let's assume that. Like, you would then maybe do a full join and then check if they are Fuzzywuzzy matchable, but this won't scale very well unless you use some sort of heuristic. In such a situation, you already mentioned that you can take the first letter, for example, as a trick to maybe make things faster. Are there other tricks?
For 2 tables that's matching the names, I would say that because I haven't think about something else yet at this level, but I mean, these 4, these already helps a lot because, for example, if it's 2 names that got changed in order, like the 2 words got changed in order, that would already sort it out for you. But yeah, if you want it to be super quick, other than having the first character that match, maybe you can check the length as well. But there is some limitation because if it's different by length, and if you if it's not change of character, if it's adding 1 character or minus 1 character, then you can't check that as well. So there will be limitation. That's for me. It's just my trick is more or less like a patch, like a quickly get things done quickly. So yeah.
Okay, another question.
Hi, here we are comparing 1 to 1, but what if you want to compare 1 to a set? Let's say you have 10,000 names and you want to figure how this specific name is rarity to compare, or uniqueness to compare to the whole set. Will you also use Fuzzywuzzy, or would you go with something else?
So if I have one name, for example, I have to match with the other 1,000 to see if there's a couple that is very similar. Is that what you mean?
No, actually, how would you measure how this name is unique compared to whole data set?
Okay, yeah, actually, yeah. If it's a match, then or like it depends on which one you choose. It will the logic will be different. For example, if I want to be if it's, for example, if it's I can. For example, it's the same. I choose the token sort ratio. So if the name is changed in order, I would just consider them the same. So I can apply, because every single one of them have a score, right? So if there is, for example, if there's 10 out of 1,000, 10 out of like 10,000 that got a score higher than 90, for example, then I would say that it's not unique. So at least like all of them need to score at a point that is smaller than certain threshold, then you can say that it's different from everything else. So, yeah. Yeah, I hope that answers your question.
Do you have any more questions? Okay.
Yeah.
So before you said you picked 85, if I remember correctly, as a threshold, right, for saying.
Yeah, that's the threshold. Yeah.
So how do you know that matches with a score below 85 cannot? So you don't consider anything below 85. Did you run any tests like to choose this parameter 85, or how did you pick it? And
I did run a couple of times actually. That's I didn't show it, but because as this one, the 85, it gives me 57 of them that is considered the same, like matching, right? So I look at them, but I can also change it. For example, change it to 75, and then it will give me, for example, let's say it give me 200, and then I can compare the two. Or if I have prior knowledge, knowing that all the mistake won't be more than 1%, let's say, then I could have a look at the number that is got matched and then compare it to the total. Is it less than 1% or is it more than 1%? So I can kind of I need to still fine tuning it. So that would be it's not absolute. Yeah.
Okay. Here we have another question.
Hi, did you ever try it on longer strings? So could you, for example, find a company name in a large text? Would that scale the library?
A company with a...
So if you have a large text and you want to know if a company name appears in this text, do you think you could use the library for that?
Yeah, that would be, of course, if it's a not so big paragraph, maybe like you can do some windows that slide through, and then you can do some maybe like partial ratio and all this to see if the company name appear in that window. But I haven't tried that out, but I do think the sliding window would work if you kind of have a paragraph and you, for example, your company name is consists of 3 words around normally a 3 word, then you can have a window of 5 words and slide through, and then to see how many of them is having a high partial ratio, then you can kind of pick that chunk out and know that it's a match. Yeah.
And so the last question.
Yes. Have you tried phonetic algorithms? Because I think that would work very well for short names. Because you only use it for short names, right? Not for long corpus. Yeah,
this one is for short. So what's the algorithm that you mentioned?
Phonetic algorithms.
Oh, phonetic algorithm. Is it? Oh, yeah. I haven't tried that one because it's just because I just tried this fuzzy matching, but I haven't tried that. Yeah.
Okay. And just to answer, maybe Finn's plateau or Finn's method could be a good match for your question. Yeah.
Okay, I'm afraid we don't have any more time for questions, so let's thank Cheuk once again.
Thank you.